So evolution does not have a goal. During this process of evolution of life over the time of our planet, evolution is more like tinkering. Evolution takes the diversity that exists, uses the process of natural selection to choose what is helpful at my current location and my current environment and what is not helpful, and then selects for the things that are going to allow organisms to reproduce more effectively. So through this tinkering, evolution ends up resulting in really striking evolutionary adaptations, like novelties, that seem to match an organism's environment really well. When Darwin first presented this idea of natural selection as a mechanism for evolution, one of the first kind of arguments against it was that there's no way we came up with things as complex as the compound eye, like in humans, through the process of natural selection. And the flaw in that argument was the idea that a simpler eye wouldn't have been as useful as a complex eye, or wouldn't have been useful at all to an organism. And what we've seen over time is that the development of the eye has happened in stages, and we didn't go from not having eyes to having complex camera eyes. We actually went through kind of stages. So the very first, most simple eye was probably a single nerve and a small patch of photoreceptors. And this wouldn't be able to distinguish color or shape. All it would be able to do is tell something dark versus light. But that's a huge advantage over something that can't distinguish dark versus light, because a shadow or darkness might indicate there's a predator. And so an organism with this dark light receptor might be able to now move away from something that would be potentially harmful. And then over time, this can become more complex, right? Now that we have photoreceptors, we can develop a small little eye cup. And then eventually that eye cup could invaginate further, fill with fluid, and now we have the ability to kind of refract light through this fluid, which is going to give us clearer images. And at each stage of complexity, the more complex eye will provide some kind of advantage over a different organism that didn't develop that. And then the one that has the advantage is going to go ahead and reproduce more, share its genes with the next generation, and produce more and more individuals with that type of eye. And then eventually, maybe something hardens in here. We get a lens that's able to help refract light, to not only just make an image, but to be able to focus it. And then eventually ending up with a complex eye like humans have, where you can actually adjust your vision to focus close to you and far away from you, depending on where you're looking and what you want to look at. And so this is a complex eye in a squid. But you can kind of see through this progression that it's plausible that we were able to make this complex novelty from a series of small steps, starting with just a light-dark sensor. So sometimes we make novelties out of things that already existed, and we use them for a new function. So we saw an example of this with the mammalian jaw joint. So it used to be a articular quadrate jaw joint, and now mammals, have a dentary squamosal jaw joint, and we use our articular and the quadrate in our ear instead. So that's something called an exaptation, where we're going to take a structure that used to do one thing, it used to open and close the jaw, and co-opt it, right? Kind of steal it to do something else. And we're going to steal it to become little tiny bones that vibrate in your ear to help with the transmission of vibrations. And as an organism that lives above, in a terrestrial environment where hearing vibrations is super important, that's going to be an adaptation. Think about birds. What is the function of feathers in a bird? Right now, in most modern day birds, so here we've got a dinosaur. This would have been a heavily feathered dinosaur here. This is Archaeopteryx, so that's the first bird. And then here's kind of more of a normal bird that you would recognize today. And if I said, what's the function of feathers, you would probably say for flying, right? So feathers have a really cool shape. They can be used for lift, drag, and they help the bird fly. But go back to this dinosaur here. This dinosaur has feathers, but it definitely cannot fly. So the original function of feathers was not for flight. That's something that happened over time. The original function of feathers, we think, was actually probably for warmth or for like signaling between species or mates. Even Archaeopteryx, who had wings and feathers and is considered the first bird, he's got this long tail feather here, wasn't very good at flying. Archaeopteryx had to take flight from a running start from a high ledge. So the feathers on its body were starting to be co-opted for kind of gliding, but not really for taking off in flight. Feathers existed for a long time before they were ever used for flight. So that's an exaptation of using something that might have been started as an adaptation for keeping your body warm, and then eventually co-opting it into an awesome mechanism for flying through the air.